Children, let me help you out on some stuff. Thursday, I am going to take your guys' questions, help you out. Anything that we didn't really understand, I can draw it maybe for you a little bit better. Hopefully you did okay 1 through 5 tomorrow in class. I'm going to give you 6 through 10. Some of you guys didn't get 1 through 5. The printer broke down. No big deal. I shared the link on Canvas as well. You can access all the questions if you want to, okay? All right, let's get through this kind of quick. Some of it's going to bog us down just a little bit because of this calculator use. All right, so again, I'll pull up my TI-83 calculator because I am not able to, uh, pull it up to where you could see it. So I've got it pulled up here. I'll go through it. You write it down as you go because you will have to know some calculations to some of these problems here on the TI-83, going through normal CDF, normal PDF, inverse norm, things that we've worked with, and then our tests, right? So let's just go through it. All right, so here we go, number 6. Number 6, bake sale, common event to raise money for elementary schools. Local newspaper selects a random sample, 40 bake sales in the area. From the sample, the average, the mean number of baked goods was sold, 214 standard deviation, give or take, 10.4. Each bake sale, the baked goods are sold for $5. That doesn't change. Okay. Determine the amount raised for the sample, 40. The writer of the newspaper is going to multiply the number of baked goods sold by $5. What's the new mean in the new standard deviations? In one of the chapters, were we allowed to multiply? Well, yeah, the mean and the standard deviation both can be multiplied. Addition, subtraction was a little bit different. Here we're just multiplying. They said multiply the number of baked goods. So we're just going to get a new mean based on whatever the amount was sold times, the $5 that was raised total, $5 total. All right, so we're just going to multiply. Very basic, very easy. Okay, they try to confuse you in here just a little bit. We got 214 times 5, so we got 1,070. Already I can eliminate A and B because the mean and the amount profited or sold, whatever, is not the same thing. One's talking about how much was sold. The other was talking about, the profit that we got from it. $1,070 was our profit, basically. What about the new standard deviation? Well, that can still be multiplied as well. 10.4 times 5. So now I've got a mean that is based on the amount of money raised. I've got 214 sold, but I got 1,070 that I raised. Give or take 10.4 sold, give or take $52 in the amount raised. What answer is that? That looks like D to me. This is D. There we go. All right. Very good. Number 7. A little bit confusing on this one. We really need to, let's see if we can draw this. I could pull up other websites if we need to. I'm just looking at a basic bell curve. I'm going to draw it the best way I can. It's in orange. Bell curve. You guys know I draw my bell curves weird, right? It's got a mean of 100. So if I put the mean, and it really don't matter, I can put a mean right here and just say, that's the symbol for mean. It's got a mean of 100. Let's just put that. 100 standard deviation. So 10 over this way is, 110, 110, 120, and 130, right? Backwards, minus 10, 90, 80, 70. And usually, I'm drawing it very weird. We go about 3 standard deviations from the mean, and that tells us where our values are, right? Um, Remember something like this. If I said one standard deviation over is around, what is that, 68% of all of my data, right? And then the further that we get away from it, you know, the more that my data percentages increase, right? So three standard deviations, that's like 99% of my data. What I want to know, between what intervals is the proportion greatest? Well, this is what we need to think of. Usually, if we did a histogram and it's normally distributed and I ask for the mean, a lot of our data is going to be very, very close to the average, to the mean. So let's just, count from 90 to 100. From 90 to 100. This is what we got right here. That's only 10 steps away from our data, or excuse me, 10 steps away from the mean. So, you know, let's look at some more. From 100 to 110, that's 10 steps away. That's okay. I'm looking for something really, really close. I mean, that's 10 steps away. That's 10. I mean, these two answers are almost the same. you know so what about from 80 to 90? Well, that right here, 80, greater than 80, less than 90, in between here, kind of far away from the mean. I'm looking for something really, really close to the mean. Well, how about this? How about 95 to 105? 95 to 105. Well, that's very close to the mean, 5 steps in either directions from the mean. This is going to be a value that's got the greatest amount of, proportion, I guess you would say, between that interval. 110 and 120, well, that's the same as 80 and 90, right? Same thing here. That from 95 to 105, if it's really, really close to the mean, that's the proportion that has the greatest of the values around the mean. That's really what it. I'm not saying it really well in so many words, but that's really what we're saying. 95 to 105. Yeah, if they're really, really close to the mean between those two intervals, the proportion is the greatest. Okay, and that's the majority of where my data lie, because I mean, gosh, that's the mean anyway. That's the average of all the values, right? Is right there. So number 7 is D, between 95 and 105. Kind of can use the empirical rule on that, the percentages of values as we go away from the mean. Those values get smaller and smaller, kind of. But when we're talking about the totality of everything, we get close to 99% of all of our data. Okay. Hopefully that was okay. Uh, Number 7. Yeah, that's D. All right. Let me clear this out right here. All right. Let's go on to number 8. Number 8. All right. And this is where we're going to use our calculator quite a bit. Different ways in which you can do it when applying to law school. This person, Gertie and Kavita, they both took law school admission test, LSAT. Distribution of test scores for the LSAT, it's normal with a mean of 150, standard deviation of 10. Gertie's score was at the 82nd percentile. And Kavita's score was 1.2 standard deviations above the average, above the mean. Which of the following is the approximate percentile for Kavita? Oh, so they want us to convert 1.2, which is a z-score, into a percentile. Well, no big deal. Actually, let's do let's do kind of both. Let's draw it first. Let's draw it. Let's get another color besides, let's just do dark gray, it says. All right, if you guys can see this, all right, so we've got a mean, where are we at? Where are we at? Where are we at? Mean of 150. So it's like 150, and I know I'm not writing it clear. I'm having to write on my screen. Mean of 150, which is the 50th percentile. This person is 82nd. Well, it's super easy to find out what the actual score is. So I'm looking for a score that's like 150, 160, something like that. 82nd percentile might be, somewhere in there, right? So let's use our calculator. Remember, and we just went over this kind of either last week, maybe a week before. How do you find a z score, or how do you find a score in general given a percentile? Okay. How would you actually do it? Well, we're going to go to our calculator, and I know you can't see it necessarily. So we're going to go to inverse norm, which is second distribution, inverse norm. Okay. And on your calculator, it's going to be just a little bit different. And it's going to tell me a score, right? So I'm going to say 0.82. Is that what it was? Yeah, 0.82. What was the mean? It was 150. What was the standard deviation? It was 10. They're going to give me a score. This is 159, and that makes sense. If you put that in your calculator, just like what I said, what score, right, is in the 82nd percentile, right? And you can tell me using the z-score formula, you can put 159 minus the mean, which was 150, divided by 10, and it's going to tell you how many standard deviations above the mean that actually is. Well, that's really not the question, but I just wanted to show you that. Okay. How do you convert percentile into a score and the score into a z-score? Remember, z-score, how many standard deviations above or below the mean a given value might be. Okay, that's how you use your calculator. Well, to do this also, right here, 1.2, and change it into a percentile, we're going to do the exact same thing except backwards. Okay, we're going to go second distribution again, and now we're going to go to a normal. And remember, when you get a percentile, it's that percentile at or below, that's where you are. Okay. So it's not a normal PDF. It's going to be accumulation of values, which is normal CDF. So we're going to go to normal CDF. Okay. We're going to put that score in 1.2. Okay. And because it's a Z score, a Z score always has a mean of 0, a standard deviation. Oh, excuse me. Let's go back. Let's go back. We need the range of values. Range of values. So if I, and I'm gonna draw it again. I'm gonna draw this again. If I were to say, 1.2, I don't know where that is, right? Let's just take a guess. It's about right here, 1.2 standard deviations above the mean, above 150, right? Well, 82% of, I'm looking for this. I'm looking for all this shaded region in here, right? Up to 1.2. Well, what percentile is that? Well, let's put in our calculator negative, right? Infinity, which what do we do for that? We say negative 999, comma, now up to what? 1.2. That's what I forgot. With a mean of 0, with a standard deviation of 1. And it looks like to me I got 0.88, which means I'm in the 88th percentile. Not 12, not 84, not 84, 88th percentile. Well, tell me, is Kavita's 88th percentile above or below Gertie's 82nd? Well, it looks like here it's above it. So Kavita's score was 88 and was greater than Gertie's, not less than, greater. So therefore, we're going to say D is our answer for that. Okay, that's one of the ones maybe Thursday I need to get on the board and really draw it out for you. This is not the greatest platform that I can come up with to help you on that. Okay, hopefully you understand that. Again, and like I said, pause the videos, go through it, see if you can, and then use me. Right, just use me, and I'll help you out as much as we can. Okay, all right, two more, and we're gonna get out of here. Excuse me, I got the hiccups. All right, some of you guys may remember doing this. Again, pause the video. This is number 9. See if you remember doing residual plots. Remember, we did this all the way back during Halloween almost, and we did a pumpkin uh, in a residual plot. Uh, the researcher fit a least squares regression line, right? When you get a least squares regression line, in a scatter plot, you want to know how good that line is, right? And the way that we do that, we look at a residual plot. And again, we can do that on a calculator if we need to. If the residual plot shows some sort of pattern, that means our original least squares regression line was not a good fit. Okay, so let's look. All right, so we got some above, we got some below. No big deal. Does this show a pattern at all? You know, like a U-shaped pattern, anything like that? No, I don't see a pattern here. So really, this model is pretty appropriate. The residual plot has a random scatter, which it does. Therefore, the linear model is appropriate. B is our answer for this one. Let's look at the other ones. Clear pattern, not really a clear pattern. It's random. Yeah, so it's not clear at all. Residual plot and strong correlation are not sufficient enough. You know, no, it's really the residual. If it shows a pattern, that's really all we're looking for. Did we mark off a good least square regression model in the original data plot? Is that a pretty good model? Yeah, this is a pretty good model because the residual does not show any kind of clear pattern. Good. All right, that is B. All right, number 10, last one, last one. All right, this is interesting. So 9 and 10 are based on least squares regression. Now, this is the original data, bam, social media budget, and then what was their sales, on the y-axis. So suppose there's a company, we got all this data right here. Here is our model. What if I added stuff to this model? What does it do to the line? Remember doing this? If it's really, really close to the middle, it really pulls it up and down. If it's close to the ends of our line, it really changes the slope, right? Changes the y-intercept. Okay. And so suppose a company has an annual budget of 7 million right here. So somewhere right here, okay, let's get it exactly. And 100 million in sales. Here's 100 right here. So let's match up 7 and 100. So let's say I put a dot. Let's say I put a dot, and I'm going to put it right about here, somewhere right there. Okay. What if I added that point? What's it going to do to this line? Well, it's really not in the middle. So the whole line is not necessarily going to jump up and down, but the slope is going to go this way, right? So our slope is actually going to decrease. And if this is a true line, what is going to happen to our y-intercept? Well, our y-intercept is going to go up. So it's basically going to flip kind of like that. Remember, we used to do things like this. So let's just find our answer. Let's find our answer. It says the slope will decrease, which is true, and the y-intercept would decrease. Well, that means the whole thing um, somehow goes down, and then the slope goes. I don't know. Unless you don't have really a line, that would be true. But A is not right. The slope would increase. That's not right. We're looking for something that the slope would decrease. The slope would decrease, and the y-intercept would go up. C is our answer here. The slope would remain the same. No, that 1 point, because it's a potential. Now, if it was closer to the line, maybe it wouldn't move at all. But this is a potential outlier. This thing could really magnetize the slope, right? So D is not right. The slope would decrease and the y. Well, if the slope decreased and the y-intercept, say you don't really have a line, you got to look at this. You got a parabola, you know. So that can't be true. So E's not right. C is our final answer. All right, guys, quick video today. Hopefully the printer is working. I'll get 1 through 10 out to you if you don't have it. Make sure, and I see everybody. Out of my 65 students, and I know it was senior skip day yesterday, only 11 people watched the videos. Our AP exam is coming up very soon, May 7th, and I just want you guys to be prepared. Again, I'll go over any questions you want me to in more depth, okay, and have more one-on-one time with you, okay? Until then, guys, do some of these problems on your own and then play my video and see how well you do, okay? I will see you next time.